Alright, you guys, a quick word on your upcoming test.
I wrote it down.
What we've done since break is really focus on the synthetic division, finding zeros, factoring, and graphing with multiplicity. And that will make up the majority of this test. However, you still need to be able to do things like this. That will be on there. So operations with polynomials, like multiplying them, adding them, subtracting them. We did addition yesterday. Here's multiplication. We did, I guess maybe it was yesterday. It was recently. We did a long division one. So that will be on there. We can do some more, and of course it's on your review as well. Identifying end behavior. That's part of a lot of these problems because of graphing, right? Identifying multiplicity, that kind of thing. So I'll hand out your review here in just a bit. Hopefully that stuff rings a bell. How do we do this kind? How do we do this kind? Alright, so Lillian's doing this. It's the idea of distribution, right? So we need to multiply everything by x. What's x times x squared? And then x squared y, so we multiply the x by the other x and then just stick the y at the end. And then 3xy. You could do yx, but the standard is really put the letters in alphabetical order when you have multiple letters. So xy. Okay, now we need to do the same thing with the 2y. So 2y times x squared. 2x squared y would be how you'd write that. 2y times negative xy is negative 2xy squared. So again, the x comes first, and then y times y is x squared. 2y times 3y is 6y squared. Okay, so we see a couple different x squareds and a couple different y squareds. Is it okay to combine those? Like x squared here, x squared there. Is that okay to combine those two terms? Why? Like, why is it okay? Everything is the same size and power, right? Like x squared, y is not. So we can combine those two. Anything else? Like, what about this xy squared with this y squared? Can we just do the y squared? No, because that's different, right? Things are being multiplied differently. How about this xy squared with this xy? No. We do still write this in descending exponent order. So x cubed is first. And then this becomes just x squared y. What comes next? In terms of standard form order, what would you do next? Yeah, this should be plus. Is that what you're worrying about?
Yeah.
Yeah, it should be plus. Sorry about that. Okay, what comes next? This is actually going to be our last term because it's only single powers, like 1 for the exponent. Okay, so we could go, I'm going to start crossing these off because it just gets kind of messy. That's done, that's done. We could go here, xy squared, and then y squared. It would be how you'd see this. And then our 3xy at the end. How'd that go for you? Okay, lots of thumbs up. Any questions on the homework, the 3 homework problems? The unnumbered number 1. So if you GCF out of 4x, you're already most of the way there. I mean, a good part of the way there, because all you're leaving is a quadratic that you can star. So that's the power of that GCF, instead of having to do Instead of having to do the rational root theorem on factors of 0 over 4, which wouldn't really help anyway, GCF. And don't forget that GCF is a 0 at 0. And all the multiplicities are 1. This is odd positive, so pretty much straightforward graph. That one should have gone really well. If not, I need you to come talk to me, okay? So let me know. Are we good on it? Okay. So then 16 was next. I'll have to zoom and scroll for this one. 16 is 4th degree and does not have a GCF, so now we have to do the rational root. So your possible roots are positive and negative, 1, 5, 1/3, and 5/3. Okay. So -1 hits, positive 1/3 hits. Once you get both of those, you're at a quadratic, and this quadratic stars as well. Your x plus 1 has a multiplicity of 2. Your -1 root has a multiplicity of 2, so you should have a bounce off on on x equals 1. Excuse me, x equals -1. So your graph should look something like that. How many of you are making a habit of finding the y-intercept? At least to give you an idea. You should be doing that. I will check on your test if you have done that. This one was 5, so it needed to be graphed. If it's like -200, I'm not going to ask you to graph that, but you should at least indicate that you've checked. And we've shown that repeatedly. We've shown that by dropping our loop down and just not labeling like our y-axis and putting. I've done it. Let me just show you. So it's too hard to talk through it. So you've seen me do it like in engineering when you have something far off. It's kind of a bat symbol that indicates, hey, there's a gap there that we're following. So I've done it that way, which you're welcome to do. And then I've also done, like if let's say we have a loop coming down where we've kind of done it like that, indicating, hey, this goes way down there. Either one. But show me that you've addressed the y-intercept if you want full credit on these, okay? Anyway, any questions on that one? So that was 16. Any questions with it? How'd it go? Give me a thumb somewhere, please. Those of you who have done every one of these on your own, the test problem will just be another one of them. And it will feel very familiar and very kind of routine. If you're not doing your homework and trying to do that test problem, it's probably going to feel a little bit like, whoa, I don't have the feeling of it. 17. That's 4. There it is. All right, this one happened to factor by grouping. Did anybody catch that? Okay. If not, there are, let's see, 1, 12, 2, 6, 3, 4 over 2. So there's going to be, what is that? Like 20. It's a lot of different possible rational roots. Would you like me to do that one without the splitting? If not, I'm happy to not. So what you should have gotten, whether you did rational root or grouping, was, where's my list? It's kind of a mess, honestly. I guess I didn't write a list for this one. So you should have got a 0 at -3. You should have got 2 zeros at positive and negative root 4/3 I. That, by the way, could be rewritten as 2 over root 3I. If we rationalize that, it becomes 2 root 3 over 3. So these are the same thing. It's just, this is rationalized. Do you guys remember that process? Getting right here, getting the radical out of the denominator by multiplying by it. Do you remember that? Otherwise, it's the same. Okay? Those are not graphable, so it doesn't really show up in your graph. And there's your graph.
Shelter in place. Shelter in place. Shelter in place.
You're not going to put the non-graphable.
I'll be right back.
Oh, you're supposed to shut the door. Yes. Shelter in place is that's a lot. Those are fucking just like control.
Okay, so she asked before I walked out, is there going to be some of these non-graphable zeros? There might be.
That's rude.
It's not rude. It actually makes it easier because why?
Yeah, but how do I know?
Well, what do you mean? How do you know what?
Like, how do you know how to, like, not, like...
Well, because
Like
you know
what?
the end behavior, right?
Yeah.
So, like, for example, on this one, we know it crosses through. It's probably not just going to slightly curve through. Because it has these two zeros, I want you to think of it, these two non-graphable, these two imaginary zeros. I want you to think of it like, hey, what if that had bumped down and crossed twice? There would be zeros there, so it must be bumping down, it's just not hitting the x-axis. So if you think of it like the shape would be such that it's creating two more zeros, they're just not graphable, you're probably going to get closer. Any other questions? Okay. Are you feeling good about this process at this point? Okay. And if I remember the test problem, like you could maybe have to divide 10 times, or if you happen to do good choosing, you might do 5 or 6 or 3 or 4. I don't know. It just depends what order you go in. So, do you feel like you have a process? Let me ask you that. You yourself. Here's a problem. Do you own a process that you kind of do now? Like for me, it's check for GCF, check for factoring by grouping, list my rational roots if those don't work, and then pick the rational roots closer to 0 first before the bigger ones, knowing that I may have to use a bigger one eventually. That's my process. Do you have one like that? Okay. Do you want to write something like that, or do you feel like you want to customize it for you? Okay. Sounds good. I want to talk to you about one quick last thing that will be very familiar and super easy. Okay? Do you remember transforming functions like quadratics, absolute value, those kind of things? Let me give you the reminder. If we had some parent function, our transformed function always did something like this. This was one version. Do you remember that? This would be for the quadratic. If it was the absolute value one, then we would just do that. It's the same though, otherwise. Anyway, what did A do? Okay, stretched it out. If it was what? If it was positive, didn't matter. It had to be bigger than 1 to stretch. What did this? Between negative 1 and 1, like what you guys would call a fraction, right? What if it was negative 4, let's say? Let's say here's my parent, what would negative 4 make me do? So flip and stretch. Okay? So the 4 made it stretch. The negative made it flip. How about this thing? What did it do? Yeah, it just shifted it vertically. Okay, that's all it did. And it was based on the sign. If it said +4, that would be up, -4, that would be down. So that occurs with these as well. It's just something that you're not going to see quite as obviously as when you're graphing, I mean, as you would with those others. So for example here, this 2. If I graphed a normal 5th degree polynomial, what would that 2 do to it? It's going to stretch it this way. Like, think of taking the whole thing and kind of stretching it like a rubber band. So maybe if the parent looked like this, the stretched version would look like closer together and stretched out. Does that make sense? What would this -16 do to it? It would shift it down, right? So I would need to redraw it again, like down here maybe. Whatever. And I'm not going to ask you to draw a transformed graph like perfectly. It's just going to say, what would this 2 do? What would this 16 do? Or -16. And from that, I think it's pretty easy to just describe it. Okay? So, we're not going to do even and odd functions. So that's not something I'm worried about. Okay? Normal x to the 4th graph looks like what? Okay, I'm seeing this. So x to the 4th is kind of a widened parabola. In fact, it doesn't go down below, but I'm just going to leave it there for now. So what would this 3 do to it? Stretch it out, so the arms will get closer together. That's what it would look like. And what was this -18 going to do? Okay, so wide x to the 4th, and then this one is going to come down. I should stretch it, sorry about that. So narrower and down here at -16. Negative, get glasses. How does that feel? Does it seem okay? It's familiar, I hope, right? Let's try another one. What does this one do? I didn't talk about h. We can if we need to, but what does this one do to it? Okay, what does the parent look like? Well, what is the parent, I guess? Let's just start there. The name of the parent function. It's cubed, right? What does a parent cubed function look like? Like that. No bumps. If it's just x cubed, there's no bumps. Okay, what does the 5 do? Stretches it. What does the 4 do? Moves it up. What does the -2, but really it's not -2 do? Moves it right 2. So this one would go right 2, up 4. So that's my new origin. And then I stretch this out. And that's not going to be super accurate, but it's close enough. Okay? Stretched, moved. Feeling good about that? Yes or no? Okay. There's a couple on your, should be a couple on your review about that. And that's pretty much it. Kind of did one like that. We've done that a billion times. I'm not going to ask it this way, where I give you a graph and ask you to write the function. So, do you want to write that reminder down in your notes so you can put it on your note card or not? Okay. Well, grab those. Let's do it really quickly. And that should wrap it up. So first you're going to identify the parent function. I'm leaving an n because now it's not specifically squared. It could be cubed, fourth, fifth, etc. This is the transformed version. It might not have parentheses. It might just have x, like we already saw a couple examples where it was just like x to the third with some number out front. It doesn't matter if they're there or not for what we're going to ask. Remember, A is vertical stretching. So stretch is greater than 1 or less than -1. Compress is between those two. Because if you don't read it that way, this is mathematically how you can shortcut writing all that out that I just said. But if this doesn't mean anything to you, you should write it. Stretch, if it's bigger than 1 or smaller than -1, it's stretching. Compressing, if x is between -1 and 1. Not including 0, of course. By the way, this should be an A, not an X. Sorry about that. But A can't be 0, otherwise that's not a polynomial. Okay? What does H do? If it says plus a number, move left. If it says minus a number, move right. I'm going quickly because we've written this. This is the third time now. Okay. Positive, move up. Negative, move down. What is a move called? You guys remember that word? Translation. Good job. So we say translate H units right, K units up, or something, right? We need to say how far. 5 left, 4 right, whatever. While you're finishing writing that, I'll hand you out your